So in this problem, we need to show that the three lines whose equations are given to us, they are concurrent. Okay, let us begin. So what we'll do, we're going to name these three lines. So let's say L1 is the line which has got equation 15x minus 18y plus 1 equals to 0. Then we have the second line L2. So L2 is having the equation 12x plus 10y minus 3 equals to 0. And then we have the equation for the line L3, 6x plus 66y minus 11 equals to 0. Now, in order to show that these three lines are concurrent, what we will do, we are going to form a determinant. And this is going to be a 3 by 3 determinant. The first row is going to contain the constant coefficients of the line L1. So that means we'll start with the coefficient of x, so that's going to be 15. So that's going to come in the first column. Then in the second column, we're going to consider the coefficient of y, so that's negative 18. And then we have the constant term that's going to be 1. Next, in the second row, we can choose the coefficients of L2, the line L2. So the coefficient of x, that's 12. Then we have coefficient of y, that's 10. And then we have the constant term, that's negative 3. And then finally, in the third row, we're going to consider the line L3. We start with the coefficient of x, that's 6. And then we have coefficient of y, that's 66. And then we have the constant term, that's negative 11. Now, we will show that this particular determinant, when we solve it, it yields a value equals to 0. Only then we can say that the three lines are concurrent. So what we will do, we're going to expand this determinant along the first row. So if we consider the first element in the first row and the first column, that is 15. So what we do, we are going to multiply it to another 2 by 2 determinant, which can be formed by rejecting all the elements that lie in the row containing 15 and also all the elements that lie in the column containing 15. So that means we are now left with 10, negative 3, 66 and negative 11. Then to what we do, next term will be negative, but we have a negative 18 number here. So we have negative 18. So that is going to get multiplied to another 2 by 2 determinant, which can be formed by rejecting the terms, rejecting the rows and the column that contains negative 18. So that leaves us with 12, negative 3, 6 and negative 11. And then we have the third element, so that's going to be the third term. So we have positive 1 multiplied to a 2 by 2 determinant, which can be formed by rejecting the row and the column containing the value 1. So we are left with 12, 10, 6 and 66. Okay, so let's expand each of these 2 by 2 determinants. So we have 15 multiplied to, so we have 10 times negative 11, so that gives us negative 110. Then we have negative 66 times negative 3. So that's going to be negative 198. But we already have a negative number, so we're going to get positive 198. The negative and negative 18 becomes positive 18. So 18 gets multiplied to, now we have 12 times negative 11, so that's going to be negative 132 minus 6 times negative 3, that's negative 18. So we're going to add it to negative 132 to get positive 18 plus we have 1 multiplied to 12 times 66. So that's going to be 792 minus 6 times 10. So that's 60. Okay, let's further simplify. Now what we have here is 15 multiplied to negative 110 plus 198. So we can use a calculator. That should give us 1320. Then the next term, that is going to be negative 2052. And the last term, that's going to be positive 732. So when we subtract negative 2052 from 1320, that's going to give us negative 732. So that gets added with positive 732 to give us 0. Now since the determinant comes out to be 0, we can say thus the three lines L1, L2 and the line L3, these three lines are going to be concurrent. Concurrent means they are going to have a common point of intersection, hence proved.